In the last reaction, we saw hydration of alkene, and we saw there is formation of pure carbocation. So there was possibility of rearrangement of that carbocation. So if we are adding a reagent, that reagent might add to some other carbon apart from those two who are making the pi bond. These two carbons here are making pi bond. Carbocation preferably will be formed on second carbon because its second carbon is 2 degree, first carbon is 1 degree. But because of rearrangement, carbocation can shift from second carbon to some other carbon in the substrate, and a substituent can add, a reagent can add to some other carbon in that substrate. Now in subsequent two reactions, we are going to see if we want to add OH group either to 1 or 2, that can be done using some reaction that we are going to study now. Like oxymercuration, demercuration is a reaction that regioselectively adds OH group to second carbon. That means if we use the term Markovnikov and anti-Markovnikov, then oxymercuration, demercuration will give a Markovnikov product without rearrangement. That means if I have to choose between 1 and 2, the OH group will get attached either to 1 or at 2, not to any other carbon because of rearrangement, because there would be no rearrangement in the two reactions that we are going to see. In the first out of those two would be oxymercuration, demercuration, and in this reaction the addition is Markovnikov addition, and OH group adds to carbon number 2. Let's see how the reaction would proceed. Before we see the mechanism, let me show how would you write the product. Suppose this is a alkene and this R group is any alkyl group. In oxymercuration, demercuration, we take mercuric acetate. And we take water. And in the second step of the reaction, we take sodium borohydride. Now this gives us Markovnikov product. Addition is Markovnikov addition without rearrangement. Meaning out of these two, OH group will get attached to the carbon which is more substituted. And this carbon, because it is second degree carbon, is more substituted. So OH group will get attached to second carbon. But there would be no rearrangement, and a hydrogen will get attached to first carbon. So it is Markovnikov product without rearrangement. Fine. Now let's see the mechanism, how it proceeds. Now mercuric acetate would be forming bond like this. And we have a alkene. Now this, when we write this as first mercuric acid plus water and second sodium borohydride, it means that when reaction with mercuric acetate is complete, then we are adding sodium borohydride. We are not adding them together. So initially in the reaction, in the system, there would be alkene, water and mercuric acetate. Now water, as I have told you earlier, is electron rich species because oxygen has 2 lone pair. Now water is not going to interact with alkene because alkene is also electron rich, water is also electron rich. Now the reaction can begin with mercuric acetate because mercury is in divalent state. Mercury has +2 charge and this acetate has -1 charge and -1 charge. The bond will not be a covalent bond as it has been shown. It will be a kind of attraction between mercuric ion and acetate ion. The bond will be kind of ionic bond. But this acetates are attached with mercuric ion, and in the solution it will not be a pure ionic bond because there would be some amount of dissociation. It will not be a pure covalent bond either, but these acetate ions will be attached with some force of attraction with this mercuric ion. Now what will happen is, this is electron rich, and electron always get transferred from electron rich species to electron deficient species. Now because mercuric ion is electron deficient, some amount of electronic density from this alkene will get transferred to this mercuric ion. Now when that happens, as we have seen tons of time before, that when mercury ion will start to form a bond with this carbon, when electronic density from this alkene will start to get transferred into this orbital of this mercuric ion, it has to break a previous bond, and one of the acetate ion has to go away. Now gradually a bond will be forming between this alkene and this mercuric ion, and this bond would be breaking between acetate ion and mercuric ion. Now when that completes, when that process completes, I'm just showing that in one step. When that happens, then suppose, for the sake of understanding, I show you that this mercuric ion forms one bond with this carbon, and other bond with acetate ion is intact. Then there will be a plus charge on this carbon developed, because this carbon will be devoid of its one electron, as we have seen many times before. But this will not happen like this, because mercury has a lone pair, and that lone pair will be giving some amount of electron to this carbon having plus charge. So this kind of a structure will never exist. But for sake of understanding, I have shown you what would exist is, there would be a bond formation between mercury and this carbon. And because of that coordinate bond, this mercury will develop a plus charge. So this intermediate will exist in this form of cyclic mercurinium ion. So the cyclic mercurinium ion would exist, as we have seen before a similar kind of intermediate, that was cyclic brominium ion. If you remember the addition of Br2 on alkene, if this is a alkene and we added Br2 to this, then one bromine gets attached to this carbon, this Br comes out as Br minus, a plus charge ought to be formed on this carbon, but the pure plus charge is never there, because bromine has lone pair, and those lone pair are involved in making cyclic brominium ion. We have seen this reaction when we saw the addition of halogen on alkene, and this bromine has a plus charge because of formation of that coordinate bond, and later this Br minus comes and break this cyclic ring and get attached to the one carbon, and this bromine get attached to this carbon. So we have seen this reaction. So a similar step will repeat here. Once we have cyclic brominium ion, then in the next step we haven't added sodium borohydride yet. So in the next step all we have in the system is water, and that water will come and break the cyclic ring,